we'll start the recording right now. We'll be recording these lectures, and the lectures are, well, the whole class meeting, not just the lecture, and these will all appear on my YouTube channel. Again, I'll send out emails with links periodically, and then the links for these things are on the pilot page as well. There's the link for my personal website, and then there's the YouTube channel. So you can see all my lectures from previous semesters. I did teach this class last semester, but the format's going to be a little different this semester. So I'm not sure that these videos will be useful for you. But we will be recording all of these class meetings, and all the notes will be online. However, we do need to attend the meetings so that we can talk together. Also, this is a very small class, so if you want to talk, please talk. I encourage everyone to turn your microphones on and to speak freely. Okay? So just turn them on, speak freely, ask questions. There's no need to use the hand-raising mechanism or send chat messages. We can just talk together. It's a very small class, and there's no, that shouldn't cause a problem at all. All right. Where were we? Course policies. All right. So, here's the URLs again for the YouTube and for the personal website. Oops, this should be a carriage return here. The final exam is Wednesday, April 28th. So that date's right there. Oops, I didn't put the time. I'll update this after class. It's so that we know when the final exam is. The percentage breakdown of the grade is as follows. So homework is 40% of the course, and then we'll have 3 exams, 20% each. So this is a writing intensive course, or writing across the curriculum, as it's called at Wright State. So it's a course that seeks to develop your writing skills. So a significant portion of that, is going to be from the homework. The exams, of course, we do our writing as well, but sort of the most practice you're going to get writing is in the homework. So that's the that's a main portion of your grade. So the homework is 40%, and then there's 3 exams, 20% each, and then we take a weighted average of those 4 different grades, right? There'll be a homework average, and then there'll be a weighted, then you'll be your exam scores. We take the weighted average of all those things, and then here's the letter grade that goes along with these. 80% is an A, not 90. 80 is an A. 65 is a B. 50 is a C. 40 is a D, and less than 40 is an F. The grading scale is quite low, but it's not inappropriate for this kind of class. Okay, this is going to be challenging for most of you, this class. This is unlike any math class you've taken before. In the United States, we don't typically teach mathematics from a writing perspective, from a logic perspective. Mathematics is taught simply, by doing calculations. And in lots of other places it's true as well, not just in the United States. In some places in Europe they do, more sort of proof-based work in high school, although not that much. So this is definitely going to stretch your mind a little bit. So you're going to have to spend some extra time on the material. Okay, spend some extra time on the material, and don't wait till the last minute to do the homework, because it won't happen for you. You'll get to it, you'll look at it, oh, I can't do it, and then that's it. You got to start the homework assignments as soon as you get them. Okay, again, it's a writing course, so we're developing your writing skills, and the writing skills that we're going to learn here and work on here, they're not just writing skills like specific to mathematics. It's just good technical writing skills. All right. So as far as the homework goes, office hours. Attendance. I require you to be at class meetings. Of course, I can't really tell if you're, if your username is showing. I can't really tell if you're, if you're here. You can be off watching TV or something. But normally in the face-to-face classroom, I require your attendance. But I'm not going to take attendance, and you're not going to be penalized for not being here. But I do expect you to be here. Office hours. I think it's good for us to make appointments for office hours. Email me and we can set up a time. It's easy to do. I've got plenty of free time when we can meet. So if you need extra help, okay, email me or just talk to me right after class. Right, we're here, we're together now. So when the lecture is over, just stop me before we're done and say, hey, I'd like to set up a meeting time when we can get together. Okay, so so please, come to me for help if you need it. Yeah, that's what I'm here for. So the homework assignments. So here's the first homework assignment. All right, and that's going to be due on Wednesday, the 27th by 5 p.m. But you need to start it today. Well, I'm not sure how much of the material we're going to be able to get through today. But you're going to need to start it today or Wednesday. That's 2 weeks and 2 days from now. But you got to start it right away, okay? If you start it the day before, chances are you're not going to be able to finish it. Okay, it's going to take some extra time. So please don't wait till the last minute, and I'll pester you about it during class time as well. I'll ask, are there any questions? Do we need help with this or that or whatnot? So homework assignment is due on Wednesday by 5 p.m. and then at 5 p.m. I'll put up solutions to the homework. So you'll have the solutions to the homework assignments. And because I'm posting solutions for the homework assignments, I can't accept late assignments at all for any reason. Okay, so there's plenty of time for you to get started on the homework, so you got to get started on it early. And I can't accept late assignments for any reason whatsoever. If there's like some really unforeseen circumstance, we can, possibly drop some of the homework grades, but I can't accept a late assignment at all. All right. The first homework assignment, by the way, there's not much as far as proofs go just yet. What we do need to do is go over the language of what's called propositional logic. So this is just a practice on the language of propositional logic. So no actual proofs on the first assignment. All right. There's the syllabus for the course. Basically seven different chapters. And all the notes again are going to be online. All right. Any questions on anything before we get started? Anybody? Any questions?
I take it your advice about not waiting until the last minute.
Yeah. Yeah, you don't want to do that. Okay, so as soon as you start on the assignments, you're having some trouble, let me know and we can set up a time to talk, or we'll talk about them during class time as well. All right. So, anything else?
Do we submit the assignments on Pilot? Like, how do you want us to submit them? Do they need to be typed or scanned?
The Dropbox on Pilot. I'll let you know. Basically, write down on paper first. So let me write this down since you asked. So homework assignments will be submitted. Via Dropbox on Pilot. Okay, so what you'll do is you will complete your assignment with pencil and paper. Okay, and then what you're going to do is scan your assignment into one PDF document and upload to Dropbox. Please use Adobe Scan or Cam Scanner or some other appropriate smartphone app.
This app has the.
Sorry,
Are we allowed
you're cutting out there. What do you want to say it again?
on the iPhone? Are we allowed to use that?
Allowed to use what? I'm sorry, you're cutting out there.
The Notes app.
Notes app. Does that have scanning on it? Is that on your phone? Oh, I see. You want to use like Microsoft OneNote or something like that and write directly on the screen? Is that what you're saying? So is that writing directly on the computer like I'm doing?
Yeah, that's it.
Okay, yeah, that would be actually ideal. Actually, I realize not everybody has that sort of thing. It allows you to scan documents as well, right? I mean, not everybody has access to to a pen tablet like this or something else. And they're a little pricey as well. But you don't need that. Just do it on pen and paper. If you have it, that's great. If you don't worry about it. Just do it on pencil and paper, and then use a smartphone app for scanning. Please don't use a flatbed scanner. If you do use a flatbed scanner, set the resolution way down and make the scans 8.5 by 11 in size. So, when you use the flatbed scanners, those are often calibrated to, scan, photographs and things like that. I mean, and then the files, they just become these huge things. I mean, each assignment should be like a megabyte at most, typically less than that. And when you use Adobe Scan, that's what you get. These smartphone apps are calibrated for doing this kind of thing. But people send me these things that are like 70 megabytes or something like that, from a flatbed scanner, and then it's just really difficult to deal with. Okay, so I mean, if that's all you've got, fine, use the flatbed scanner, but you got to set the resolution down and set the scan to 8.5 by 11, not like some very large size. So one PDF document, and then you'll upload that to Dropbox. Okay, it's really easy once you do it a couple times. The smartphone app, they work really well. So please, and these are free. Adobe Scan and Cam Scanner, those are free apps. So you can, they won't cost you anything as long as you have a smartphone, which I'm assuming most of you do. If you don't, then we'll talk about it some more. All right. Anything else before we can start on the lecture? Anybody? Okay. All right. So chapter 1. Is on propositional logic. So definition: a proposition, okay, or statement, it's sometimes called or often called. The statement is sort of the more common term, and proposition is the more highbrow term. Is a sentence, or a part of a sentence that can stand on its own. Which is a sentence itself. That has a definite truth value. True or false. So, for example, when the sun is shining. Well, maybe even that one is a bit of a... So 4 is even. So 4 is an even number, right? That's true. 9 is a prime number. Right? That one's false. Something like this. Mark. Mark has black hair. Well, I mean, that's true or false depending on who Mark is. All right, so all of these things, these are propositions or statements, and they have a definite truth value, true or false. So non-examples. Mark is tall. So, well, I mean, it depends what you mean by tall, but this is a value judgment. Do you like chocolate? All right, this is a question. It's not like something that's true or false. It's just a question. 3. Barney horse. Why is this a non-example?
It's not a sentence.
It's not a sentence. Okay, so propositions have to be sentences, or the parts of sentences that could stand on their own as a sentence. So that's basic idea of a proposition, definition of a proposition. And then one thing that you can do with propositions is you can connect them together. So logical connectors connect propositions together to get sort of larger, I guess you could say, compound propositions. Okay, so the first logical connector is known as conjunction. So conjunction, which is symbolized by this thing right here, given propositions A and B, the truth value of proposition, so A conjunction B, is given in the following table. So here's A, B, and then A conjunction B. So I make this table with oops, it should have 4 rows. I'm missing a row. I make this table with 4 rows because there's 4 possibilities for the truth values of A and B. It could be that A and B are both true. A is true and B is false. A is false and B is true, or they're both false. And in this case, the truth value of A conjunction B is, in this case, when A and B are both true, the conjunction is true. And in all other cases, it's false. So in English, conjunction means something like this. A and B can mean, well, A and B is sort of the standard one, although there's lots of other ones as well. A, furthermore, B. A, moreover, B. A, however, B. Anything else? but B. Now, it's kind of like these last two have sort of a negative connotation to them, right? A, however, B. A, but B, right? Something like this, like, right? It's not raining, however, it's still cloudy outside, or something like that. It's not raining, however, it's still cloudy. So it means it's not raining and it's cloudy. The however, gives it sort of a negative connotation, or gives it somehow an unexpected connotation to it. Something like the following. I left the house early, however, I arrived late. I left for work early, however, I still arrived late. That means I left for work early and I still arrived late. Right? It just means and. It's just conjunction. The however part gives it sort of, some sort of prosaic flair. Like, the I left the house early, however, I still arrived late at work. Give it something unexpected about B, or something negative about B. Or A but B. Same sort of things. But these are all just sort of prosaic flair to it. It's not anything different than and, as far as the pure logic goes. Okay, so A and B, or A conjunction B, is true only when A and B are both true by themselves. Okay, if one of A or B or both are false, then A and B is false. Right, and that's typically what we mean in English using the conjunction and, right? Conjunction can also be used to connect three or more propositions. So if you have A1 and A2 and AN, like that. So it's just a conjunction of n propositions. So this is true when each AI is true on its own. Okay, if any one or more AIs is false, then the conjunction of A1 to AN is going to be false as well. Then the conjunction A1 to AN is also false. Right, and that's what we mean in English typically when we use the word and to connect a bunch of things together. So something like the following. The table is level and my walls are white, which they are, and we're meeting remotely, and I have a stapler on my right. So that's true, because each one of the things I said is true. The table is level, and my walls are white, and we are meeting remotely, and I have a stapler on my right-hand side. So each one of those things is true, so the conjunction of them is true. But if I had any one or more things that were false, the whole conjunction would be false. Right? The table is level, and the walls are white, and we're meeting remotely, and there's an alien invasion going on outside. So even though the first three things I said were true, the whole statement is false because there is not an alien invasion going on outside. All right. So the second connector, logical connector, is called disjunction. And that's symbolized by this V shape. So similar to this setup here, cursor. Given propositions A and B, the truth value of the proposition A conjunction B, so now we're going to do disjunction. The truth value of proposition A disjunction B is given in the following table. When A and B are both false, the disjunction of A and B is false. Otherwise, if either A is true or B is true or both of them are true, then we consider the disjunction to be true. In English, disjunction can mean A disjunction B can mean A or B, A or else B, either A or B. What else do we use for disjunction? Any other ideas? Any words you've seen? A or B, A or else B, either A or B. Any other ways you can do disjunction? All right, you can have this or you can have that. Any other ways of saying this or that? There's more. Not as many as there are with conjunction, but there's more here. Either this or that. So one way you could say it is, if not, either this or that. Another way you could say it is, if not this, what? If not this, then that, right? It's the same thing as saying this or that. So now here we get into perhaps a little bit of ambiguity with English. What do we mean in English when we say A or B? Do we mean either A is true or B is true or maybe both? Or do we mean either A is true or B is true but not both? What do we mean usually? Well, it's ambiguous. Sometimes we mean the inclusive or, it's called. Either A is true or B is true or both. That's the inclusive or. Sometimes we mean the exclusive or. Either A is true or B is true, but not both. And usually people clarify when it's important, which one it is that they mean. Okay, but in mathematics we have to have a convention, and the convention is it's the inclusive or. So A or B is true when either A is true or B is true or both of them are true. And the reason why that's the convention are manifold, but I'll mention them as we go along. There is, people do also use the exclusive or, and we do use that in propositional logic as well, and we'll get to that, but it's less common. Let's see. And you can also, just like how we did a conjunction of three or more propositions into a larger proposition, you can do the same thing with disjunction. So disjunction, excuse me, can also be used to connect three or more propositions. So A1 disjunction A2 disjunction A3, excuse me, all the way up to AN, is true when at least one AI is true on its own. If all AIs are false, then the disjunction is false. Then the disjunction A1, A2, up to AN is false. Okay, now here's something that I want to emphasize. In mathematics, when we say at least one, this is a point of confusion, okay? In mathematics, so we often, say to each other when we talk in English, like, don't always be so literal, like in your understanding of the way people talk. However, in mathematics, it's brutally literal, okay? Everything has got to be completely and brutally literal. There's no innuendos or sarcasm or whatnot. When you say at least one, you mean at least one. So if I said to you, at least one person in this class, that's something I can say. At least one person in this class has 25 cents in their pocket. At least one person in this class has $1 in their pocket. What do I mean by at least one? It means at least one or more. Suppose everybody has $1 in their pocket. Does that qualify as at least one? Yes. Okay. When you say at least one, it means one or more. And one or more includes everybody. Is it inaccurate to say that in some way? Is it not telling a full story? Yes, of course. That is indeed true. However, from a purely logic perspective, when you say at least one, if it's true for everyone, then it's still the case. So if I was to say to you, the table is level, or my walls are white, or this class is meeting remotely, or I have a stapler on my right. Okay, that's true. Each one of those things I said is true, right? And each one, or all of them, qualifies as at least one, as long as there's at least one thing to talk about. Okay, if I was to say to you, the table is level, or the walls are green, or, there's a alien invasion from Mars happening outside, or, what else? I'm not sitting down in a chair. all of those things are false except for the first thing. The table is level. But because I used or, it's true. Okay, and that's typically what we mean by a disjunction. All right. So conjunction and disjunction are a little bit easier to understand. Implication takes a little bit more thought. But implication is really important. So given propositions, A and B, the proposition A implies B has the following as given in the following table. So let's copy that table again. So A implies B looks like this. So in the statement A implies B, the A part, this is called the hypothesis. And the B part, that's called the conclusion. So the part on the left is the hypothesis, the part on the right is the conclusion. So notice that the only time A implies B is false is when the hypothesis is true and the conclusion is false. One second, guys. I apologize. Hi, guys. Sorry about that. Okay. So with implication, the only time an implication is false is when the hypothesis is true and the conclusion is false. Otherwise, the implication is always true. In particular, when the hypothesis is false, the conclusion is irrelevant. The implication is automatically true. So let me write that down. So in particular, when the hypothesis is false, the implication is true regardless of the truth value of the conclusion. Okay, so this is often a point of confusion. A point of confusion for folks the first time they think about this. Okay? The only time an implication is false is when the hypothesis is true and the conclusion is false. When the hypothesis is false, the implication is true, not the conclusion. When the hypothesis is false, the implication is true. The conclusion is irrelevant. All right? Whether the conclusion is true or false is irrelevant. So, for example, when I say, something like the following. If I was to say, what should I say here? If you pass the final exam, then you will pass the class. If I was to say this to you, if you pass the final exam, then you will pass the class. So now, suppose you passed the final exam, and it came to pass that you did, and then it came to be that you did pass the class. Then did I lie to you? No. What I said to you was true. If I said, if you pass the final exam, then you will pass the class. If you did pass the final exam, yet it came to be that you did not pass the class, then did I lie to you? Yes. Okay, now suppose you failed the final exam. If you failed the final exam, well, I didn't say what's going to happen if you fail the final exam. So the statement is essentially meaningless. Okay, I didn't say to you, you will pass the class if and only if you will pass the final, you'll pass the class if and only if you pass the final exam. I didn't say the if and only if. I just said, if you pass final exam, then you pass the class. I didn't say anything about if you didn't. So the statement is essentially meaningless, but in propositional logic, you got to give it a truth value. And the truth value you give it is true. That's counterintuitive, but that's the way it's got to be. And the reason for that choice, you'll see why. You'll see why. All right. So in English, can mean all of the following. Okay, so the standard one is A implies B. The standard one is A implies B. The one that's also standard is if A, then B. But here's where it gets a little bit confusing. B follows from A. B when A. B is necessary for A. A is sufficient for B. B if A. But what do all of these things have in common? What do all of these things have in common? A implies B. If A, then B. B follows from A. B when A. B is necessary for A. A is sufficient for B. B if A. What they all have in common is the following, is that these all describe the following containment relation. Well, they all describe a relation in which instances where A is true or contains in the instances when B is true. So the diagram to think about would be this. Let me see. Some more space on this page. I didn't lay it out too swiftly here. So the hypothesis is contained within the conclusion. Guys, I have class. Oh, let's well, actually, class is over at this point. So we'll pick up next time on this. All right. So we didn't really cover too much today because we had to get things set up. So next time we'll pick up some speed. All right. So email me with any concerns or questions, or talk to me right now, and then we'll meet on Wednesday at the same time here in Collaborate Ultra, and please keep an eye on your email for any announcements that I might make. Okay. All right, guys. Have a good afternoon.